we need to learn how to write chemical equations. They use equations in math, right? Johnny gives Susie 5 peaches, and she already had 2 peaches, and how many does she have now? And they want you to make a number sentence, right? A math equation. In chemistry, we use equations. They are similar to math equations, but not exactly the same. They're a shorthand way of describing a chemical reaction. So we're going to use formulas and symbols to describe the chemical reaction. So here's an example of a generic reaction. Some compound or element A plus B reacts to form C plus D. So the reactants are the things that are on the left side of the arrow. Unlike most math equations anyway, chemical equations are directional. So the reactants react to produce the products, right? So what you start with on the left side of the arrow is the reactants, and then on the right side of the arrow, those are the products. We need to be able to identify those. We often indicate the physical state of each of the species. Species is just a word that we use instead of saying compound or element. It's just a chemical substance of some kind. So here AQ means this is an aqueous solution. It's dissolved in water. G means that this is a gas. S is a solid, and then this one is also aqueous. Not all chemical equations include all those state symbols. And then sometimes we indicate the presence of a catalyst. A catalyst is something that speeds up a reaction, but it doesn't actually get used up. So it helps things go faster, but it's not really a reactant or a product. So these are some equation symbols that you need to know. So the arrow represents words like produces, yields, gives. This is what separates the reactants from the products. The things on the left of the arrow combine in some way. They are changed, and where the arrow points is what you end up with. Plus is used to separate 2 or more reactants or products. Sometimes you will see a little symbol above the arrow. Here with the little Fe, that means that iron is a catalyst. You're not really going to be required to know, oh, this reaction needs a catalyst, but we want you to be aware of what that symbol means, that means that iron's the catalyst. Here, the little delta sign, we often use that for heat. So instead of writing heat, we make that little triangle. If it helps, you could think of that as being like a little campfire. It kind of looks like a little campfire, doesn't it? If we see NR as the product, that stands for no reaction. And then these are the 4 different state symbols: solid, liquid, gas, and aqueous solution. And then another thing we need to be aware of when we're writing chemical equations, there are 7 of the elements that when they are present as an element, they naturally occur as a diatomic molecule. Diatomic means 2 atoms. So if we have hydrogen gas, my pointer's acting up, hydrogen gas, it's not hydrogen atoms, it's hydrogen molecules, and they're H2. So whenever we see one of these 7 as an element, we need to write it as a diatomic molecule. And so how do you remember that? Those guys. Okay. Well, there's a silly sentence. Horses need oats for clear, brown. It's really great up to that point, and then this kind of gets eyes. It means eye. Horses need oats for clear brown eyes. Horses need oats for clear brown eyes. And that will help you remember the 7 diatomic elements. And those are very important to learn. Another way, another pattern that I've observed in the periodic table is if you look at the periodic table, what's element number 7? Element number 7 is nitrogen. And if we make a 7 starting with nitrogen, I really should have put a periodic table in here. Let's see if I can draw one. So there's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They make a 7 on the periodic table, but where's hydrogen? Hydrogen's off on the other corner of the periodic table, because hydrogen's the baby of the element family, and he's always breaking the rules, right? So these guys are following this really nice little pattern, and then there's hydrogen. So let's write some chemical equations. Here we have a sentence describing a chemical reaction, and we're going to write an equation for this. We need to know our nomenclature to be able to do this. So here we have mercury liquid and fluorine gas react to give solid mercury 2 fluoride. Well, what's the symbol for mercury? Hg. So mercury liquid, Hg, and then we're going to put L in parentheses because we're told that it's a liquid. And fluorine gas, is fluorine one of the 7 diatomic molecules? Yes, it is. So we need to put F2, fluorine gas, react to give. That's where the arrow goes. React to give mercury 2 fluoride. Well, to do that, we need to write the formulas for the ions, right? So mercury 2 is going to be Hg 2+, and fluoride is F -1. And we look at their charges to figure out what the formula is. We had HgF2, and then we're told that it's a solid. So we put S in parentheses. Any questions? So we're taking a full English sentence and abbreviating it into a chemical equation.
So mercury became a 2+?
Pardon me?
So mercury became a 2+ charge?
Yes. Yes, that happens. It's a chemical reaction. It started out as an atom and it became an ion. And fluorine started out as a diatomic molecule and became an ion. And that's definitely a chemical change. Let's do the next one. Zinc metal reacts with sulfuric acid to give aqueous zinc sulfate and hydrogen gas. What are the 2 reactants? Yeah, zinc and sulfuric acid. And the products? Zinc sulfate and hydrogen. So zinc metal, zinc has the symbol Zn. It doesn't tell us what the state is. When we look at this periodic table on this wall, anything with a black symbol is a solid at room temperature. If the description doesn't mention that this is at 5,000 million zillion degrees or something, then we assume that it's at room temperature. And so we can find the state from the periodic table. Most metals are solids at room temperature. In fact, there's only one that's not. So this must be a solid. Sulfuric acid, what's the formula for that? This is an oxyacid, right? Because it doesn't start with hydro. Sulfuric comes from sulfate. Sulfate is SO4, 2-. And so then we need 2 hydrogens on there. So we get H2 SO4. What else did we learn about acids? They are aqueous. When we name something as an acid, it's dissolved in water. So this would be aqueous. To give, that's the arrow, zinc sulfate. Well, we have sulfate. I'll just get rid of that. What's the formula for the zinc ion? What's its charge? 2+. So we look at that, and we've got +2, -2. We just need to put them together. ZnSO4. We're told that it's aqueous. And then the other one is hydrogen gas. Is that diatomic? Yeah, horses. So H2 gas. Any questions about that one? Acetic acid reacts with aqueous potassium hydroxide to give aqueous potassium acetate plus water. Acetic acid. I'll do my scribbles up at the top. Oxyacid, right? Doesn't start with hydro. Acetic comes from acetate, C2H3O2 with a -1 charge. So that will need 1 hydrogen to make it a molecule. And it's an acid, so we know that it's aqueous. HC2H3O2, aqueous. Reacts with aqueous potassium hydroxide. Potassium, that's K. What's the charge on potassium ion? +1. And hydroxide is what? Is -1. It's OH, right? +1, -1, we just have to put them together. KOH. And they tell us it's aqueous. To give, there's the arrow. Aqueous potassium acetate. So that's going to be potassium now with the acetate ion. And this is +1 and that one's -1, so we don't have to do any crisscrossing. We just put them together. K, C2, H3, O2. No charge because it's a compound. And they tell us it's aqueous. Plus water. What's the formula for water? Yay, H2O. At room temperature, what state is water in? It's a liquid, so we'll put an L here. Any questions? This is going to be really tough if you don't know your nomenclature, isn't it? You've got to learn the nomenclature.